Hello friends, welcome to another tutorial in electronics and communication engineering's playlist of antenna and wave propagation. This is a basic tutorial to understand a plane angle and a solid angle. This is important in context with understanding the radiation patterns because radiation patterns are solid angles expressed in terms of steradians. Towards the end of the lecture, we'll establish the relation between radians and steradians and radian and degree and steradian in terms of degree square. So stay tuned if this is something that interests you. So if we look at the definition of radian, it is defined as the plane angle with its vertex at the center. So if I take up a circle, I need to keep my vertex at the center, and the angle 1 radian would be made if I keep this length of the arc to be equivalent to r. So it is pretty simple that if we take up various sections of r, it will constitute one circumference of the circle. And how many sections do we need? We need 2 pi sections of r each to make the circumference of the circle. So that is what is needed to be understand, that circumference is a collection of 2 pi number of sections each of length r, or the full circle consists of 2 pi radians. And if we look at the steradians, it is defined at the solid angle with its vertex at the center, again of the radius r, but it should subtend a spherical surface of r square, and that can be shown like this. So you make up a cone, and this area, this black area here, should be equivalent to r square. It's pretty simple. And the angle, this solid angle that is made by such an arrangement is known as 1 steradian. And we know that the total surface area of the sphere is 4 pi, and this r square will subtend 1 steradian. So we can say that a total of 4 pi sections of r squares will be needed to make up the surface area. So again, the definition of the surface area of the sphere becomes that it is a collection of 4 pi sections each of area r square, and the entire sphere will consist of 4 pi steradians, which is super important to understand. Now we look at the relation between 1 steradian and a radian. We know that 1 steradian is the solid angle which is subtended by the area r square. So I can say that r square is made up by 1 radian into 1 radian. So 1 steradian is 1 radian square, and we know that 1 radian is equal to 180 upon pi degrees. So substituting this here, 180 upon pi square, degree square will give me 1 steradian to be equivalent to 3282 degrees square. And if you wish to write degree square, this is the symbol for degree square. This small circle in the superscript is degree, and this small rectangle in the superscript is degree square. And again, taking into account the entire surface area of the sphere, we know that 4 pi steradians make up the surface area. So 4 into 3.14 into each steradian is these many degree squares. So the total becomes 41253 degree squares. So these are the few key points that you can remember or commit to your memory while solving the numericals based upon radiation patterns. And this was it for today's tutorial. I hope you liked it. If you did, give it a thumbs up. Consider subscribing. I'll see you around. Take care. Bye bye.